So children, you know solution. So far we have seen the type of solution. So solutions are three types: true solution, colloidal solution, and suspension. Just the revision part. So solutions are three types. First, true solution. Second, colloidal solution, and third is suspension. So these are the three types of solution. So children, in suspension we do not write solution. Simply suspension means it is solution. And we will see next, we have done the true solution. Now we will say about the colloidal solution. Colloidal solution, it is also called as sol. Colloidal solution is also called as sol. S-O-L. Now children, colloidal solution is a special type of solution. It is, a special type of solution. Why? Because it appears to be homogeneous, but it is heterogeneous in nature. Coming back to true solution, what is true solution? The word true refers to the real solution. The particles are not visible. Particles are not visible by the naked eye. Why? Because in true solution, the particles of size less than 1 nm. Nm means nanometer, and 1 nanometer is equal to 10 to the power minus 9 meter. So 1 nm is equal to 10 raised to the power minus 9 meter. And so they are so small that they cannot be seen. Now coming to next colloidal solution of sol. So in case of colloidal solution of sol, the size of solute particles lies between 1 nm to 1000 nm. So this is very important part. It is between 1 nm to 1000 nm. So see the definition. So colloidal solution is a special type of solution, which appears to be homogeneous, but is heterogeneous. This is very important point. Appears to be homogeneous, but it is heterogeneous in nature. It is having heterogeneous nature, and is having several interesting properties. The properties are interesting. There are many properties we'll see in detail, and like extra stability. It is having the extra stability. Now here coming to the explanation part, children. So I will start with the example. There are several examples of colloidal solution. So colloidal solution, it is also called as sol, and it is also called as colloid simply, nickname sol, or it may be called as colloid. Examples are many, like milk, blood, fruit juices, milk, blood, fruit juices, buttermilk, and many more. Like nail paint can be taken, nail paint, oil paint, any paint can be taken, children. There are countless examples. Even smoke is there. We'll see in our high classes. Smoke, fog, mist, they all are examples of colloidal solutions. Metals like brass, bronze, they are also colloidal solutions. How interesting. Colloidal solutions have, fantastic chemistry. They have fantastic chemistry, and so they have the, very remarkable character. Now, preparation of colloidal solution. So, milk itself is colloidal solution, but we can not exhibit different properties from the pure milk. So, for this, we take a beaker, and in a beaker we take water. What is it? Now pour 2 spoons of milk. Add 2 spoons milk. So what will happen? It will become milky. So it will be, milky. There is a uniform distribution. This I am setting like this. Then it will have the uniform distribution, and so this will become what? This water will not remain as it is. The water will become milky. So in the next point, I am going to explain, as you know in the previous part, that colloidal solutions are able to exhibit different properties. And so there are several properties, and one property is Tyndall effect. Tyndall effect. So Tyndall effect, just I am going to exhibit here diagrammatically. So here, take a piece of cardboard with a hole. Here I have marked hole, and in front keep a torch. Keep torch which is on, lighted torch. So children, here there is the cardboard or hard paper with a small hole. So light will come out. As the hole is there, light will come out, and in front of this we'll have the illuminated path. The path of the light will be illuminated. This is illuminated path of light, and this is called as Tyndall effect. So what is Tyndall effect? Tyndall effect may be defined as property of colloidal solutions when a strong beam of light is passed through it. A strong beam of light is passed through it, then the path is illuminated, means path becomes bright. Children, there are many more examples. You all must have noticed. When we go in deep forest, when there is no very dense trees, primary layer, secondary layer, they are very dense. But the sunlight, when sunlight comes or sunlight percolates from the sunlight is visible from the top. So it appears in form of the streaks of light. This is Tyndall effect. Another point is when we drive vehicles, 2-wheelers or 4-wheelers, in the rainy season or in the winter season, what we see? The headlight Here light, through light, and a beam of light is seen. You can experience beam of light is seen from the strong bulb also in the homes outside, in outhouse or on the terrace. You can see when very heavy rain is there, very microscopic particles are produced. So far away bulb is seen in form of sticks. So this is the this Tyndall effect. So the illumination of path. So point is why illuminated, because the light is made up of particles called as photons or quantas, and the size of solid particles is from 1 to 1000 nanometer. So the quantas are reflected, quantas are scattered by the particles of solute. Quantas are scattered, or the particles of light, which are called as photons, also are scattered by the particles of solute, and this is the result behind the Tyndall effect. Now we'll see the properties. Now coming to last segment in this video, properties of colloidal solution. So first property, they are extra stable. They are extra stable. You all must be knowing. We keep buttermilk or chash at our home. So you see, the particles are so small that it keeps on floating. Rarely we see any particles settle down in the bottom. Similarly, when we have fruit juice, I mean pure fruit juice. So see, throughout say lime juice, it remains as it is. Slightly turbidity is there. It is not clear. So that is the point about the extra stable, because the particles so small that the particles they keep on moving in the phase. They form a phase. Solvent and solute, they form a phase. And second, Tyndall effect. Tyndall effect, or you can say scattering, simply scattering or illumination. Scattering or illumination of light beam. Scattering or illumination of light beam. Then, third point, they cannot be separated. They cannot be separated into solute and solvent by simple method like filtration. The particles of the solute and solvent, for example, we take the case of milk. So children, we cannot separate the milk into water and the milk protein or the milk fat. And so there are different more properties we will see in our higher classes. They have electrical properties, they have charges also. So this is about the colloidal solutions. And they are very sensitive, children, also. One more point you can give, that they are very sensitive. They are very sensitive to acids, bases, etc. You may say heat also. Like egg, you all must be knowing. Those who consume egg, you must be knowing. When you prepare omelette, what happens? When we pour the egg white, what happens? It becomes solid. So actually, egg albumin, what we eat, actually egg, white, it is albumin. It is a special type of protein, and when it undergoes solidification by heating, either on boiling or by preparing omelette. It becomes solid. You all know this. And it is because that they are sensitive to heat. Similarly, children, milk kept in our homes, particularly in summer season, when we do not keep in refrigerator for a long time period, if it is kept at normal temperature, so due to formation of lactobacillus, it spoils. It is also one example. Lactobacillus grows and it causes the destruction of the colloidal solution. The another point is when we prepare the paneer or the preparation of cheese or preparation of curd, how curd is made? Curd is made by the addition of little amount of curdling agent in the lukewarm milk. Similarly, many things are there. So this is all about the colloidal solution or soap.